There's already a ton of designs out there for boxes of all shapes and sizes available for you to download for free from websites like Thingiverse, Printables and MakerWorld, but sometimes you need something more bespoke, either so the box fits in a certain location or to hold a certain size thing. There are parametric designs that you can download and then just adjust the sizes to, or you can just design your own from scratch. But sometimes you need a quick and easy solution. So today I'm going to be looking at a free tool which you can use to quickly and easily generate a latched lid box of any size you want with some cool internal customization. So let's take a look. Today I'll be making a simple box to hold the custom dice which I made in another recent video. I'll link to that in the description below. All you need to do to use this tool is go to bento3d.design. This website is entirely dedicated to this box generator and is currently completely free to use. The first page we land on shows us a 3D representation of a box and allows us to choose the general dimensions. Before we get started, let's quickly jump up to the settings in the top right, where we can set the thickness. This will adjust the thickness of the walls in the grid inserts, which we'll look at in a minute. By default this is set to 2, and you can probably leave this here for most use cases. Below this is an option to show or hide the case preview. You can see behind the settings menu as I switch this, it turns the translucent case view on and off, and also adjusts the dimensions next to it, which I'll explain in a minute. For now, just click away from the settings menu and it will close it. You can adjust the depth, width and height by dragging the sliders on each of these sides to your desired value. Frustratingly, there isn't an option to just type in the size that you're after, and this dragging system does have a tendency to jump 1 to 2 mm when you release it, but it's fairly responsive, so that's not too much of a problem. Whilst dragging it, the view changes to an angle that best shows you the dimension that you're currently adjusting, then jumps back to a 45-degree overview when you release the slider. As you adjust the sliders, you'll see that the dimensions listed on the different axes around the box are updated, but they don't show the same number that you selected. The dimensions that you're selecting with the sliders are the internal dimensions of the box itself, not including the grid insert that we'll look at in a minute. If we jump back to settings and turn off case preview, you can see that this changes and the measurements now reflect what you selected on the sliders. This white cube represents the internal volume of the box, whilst with the case preview turned on, they are listing the external dimensions of the box, including things like the hinges and clasp. At this point, you want to decide if you're prioritizing the exterior dimensions so that the case fits into a certain space, or the interior dimensions so something fit perfectly inside it. If you're prioritizing the exterior dimensions, it's best to adjust the sizes here. Adjust the bars so that the exterior dimensions shown around the box preview meet your requirements. If you want to prioritize the interior space, all you need to set here is the height. Now, whilst the width and depth that you set here on the sliders refers to the interior dimensions of the box shell, the height refers to the interior space height after the insert has been fitted. So if you wanted something 100mm tall to fit inside the box, you can set the height to 100mm and the box will account for that, plus the thickness that you've set for the box walls and base and the insert base in the settings. Now, whilst it technically allows you to set up a height as small as 10mm, the generator designs a broken box where the hinges won't work if you set the height to anything smaller than 22mm, so 22mm is the minimum height that you'll want to set here. This is because the hinge and the clasp aren't scaled with the rest of the box, and this is the smallest height that will allow the hinge and clasp to work. For me, I'm prioritizing the internal dimensions, and I want this box to hold 8 dice that are 16mm cubed each. Due to the height limitations, I'll make it hold 2 sets of 4 dice stacked on top of each other, so that would be 32mm height. I also want to add a bit of tolerance, and as you can only use whole integers here, I'll set the height to 33mm. You can see that this makes the overall case height 41mm. That's because we have a thickness of 2mm, so the box base plus the grid insert base will be 2mm each, so that adds 4mm, and then a further 4mm for the lid, bringing our overall height to 41mm. Once you're happy with that, you can click grid at the top here. Now we again have 2 sets of dimensions. We have total width and total depth in grey, and then we have these other dimensions underneath in black. The total width and total depth are effectively the internal dimensions of the box, or the external dimensions of this grid insert. The numbers in black are the internal dimensions of the sections inside the grid insert. The dimensions that you set in grid will adjust the depth and width of the box to fit the insert. So if I set this to 10mm and jump back to size, you'll see that the whole case is adjusted. The internal width is now 14mm, allowing for a 10mm spacing plus 2 times 2mm insert walls. And the external width is now 21mm. But as we are prioritising the internal dimensions, and as the height isn't adjusted by this, we can go back to the grid and get this box set up how we want. To make it easier to follow, let's make the width 100 for now. You may have noticed, as I've already done it, that unlike in the Sizes tab, here you can change the grid dimensions just by clicking and typing directly into them, and you also aren't limited to whole integers in here. Now, I don't want this case to just have one big section. I want it to have dedicated slots for each pair of die. So if I click the plus sign here, it'll add a column. And equally, if I click this other one here, it'll add a row inside that column, and we'll do that again for the other column. Now you can see that you don't have to have matching rows, and the columns don't need to be the same width. I could delete this one here, and then have a longer section at the end, and then add another row to this column so we have 3 sections on this side. I don't want that for now, so I'll just return this to 2 rows of 2. The next thing we need to do is set the column dimensions. Now this is easy, as we can set an exact and unique figure for each column. As we want it to hold 16mm die, and because we want to add a slight bit of tolerance so they're easy to fit and remove, I would set each of these to 16.4mm. However, as each of these grid sections have filleted edges, and we have no control over the amount of curvature, I'm going to increase this for safety, and 17mm should be good enough to account for that. Now you can see that it's adjusted the total width of the insert, and therefore the interior of the box too, to match. Now we need to adjust the depth. One frustrating limitation on Bento 3D is that you're not able to enter unique depths for each row, so the depth always needs to be an equal division of the overall depth, also allowing for the thickness of the dividing walls, which will be whatever you set in thickness in settings. So we want this to be 2 times 17, allowing for each of the die, plus 1 dividing wall that's 2mm thick, so that would be 36mm. Once you've got your grid dimensions sorted, next we can move to download. After a second, we'll get a preview of the box with the grid insert fitted. To the right, we have links to download the 4 STLs that have been generated for you. If I translate this page so we can better see what we're looking at, there's the partition, this is the grid insert, the main unit, this is the box itself, then there's the lid and the fastener. So let's get these downloaded and imported for slicing. Once they're imported, the first thing that you want to do is repair them by hitting the red exclamation mark on each object in turn in the objects list, and this feature is going to be in slightly different locations on each slicer. This feature isn't available on Mac as it uses a native Windows service, so if you do find that you need to repair it because it's just not slicing correctly, you may need to import the file into another piece of software which can do this itself first. Looking at the front of the box, for example, you can see some real issues here with the facet normals, and this is what needs to be fixed. Whilst not always, sometimes this can prevent it from even slicing. Once repaired, there may still be some visual issues, but this hopefully shouldn't affect the slice or output quality. Once each of them has been repaired, we'll get them oriented. The case itself and the insert can just sit upright on their bases. The clasp should be sat on its end. Now the lid is a little frustrating. The slicing suggestions that Bento 3D gives suggest effectively printing it on the hinged end, which would require printing the entire thing on a raft and a ton of support material. However, their images for the recommendation also show an outdated design that doesn't really offer any alternatives. The design that is now generated has obviously been adjusted to allow flush printing with this orientation, but the problem here is because of this recess. The whole top of the lid would be a bridge. You could create a shape using add part and merge it using the mesh boolean tool, filling that space in so that the whole top is flush with the bed, but I'd like to keep this recess, so I'm just going to add some support material here and see how it comes out. No other parts here should require any supports. Settings wise, this really comes down to personal preference and depends on what your use case is, so I'll just be printing this with a standard 0.2mm preset. Assembly is pretty straightforward, though here's the catch. If you're wanting to use the lid for this design, it does require 2 non-printed parts. You require an M230 screw for each hinge. The longer the box, the more hinges it will feature. This one just has 1. As well as 2 M228 locking bars for the catch, also called a parallel pin. To assemble it, take one of the locking pins and slide it into the hole at the back of the latch. Then take the latch with the locking pin fitted and slot this into the lid. This should clip in place and stay nice and secure. Next, take the main base of the box and take the other locking pin. This should then slide into the hole here and you need to push it up until it clips into place. Next, take your screw and prepare it at one side of the hinge. Slot the lid in between the hinge and then screw it in. I would definitely recommend using an electric screwdriver like a wow stick if you have one. Finally, just insert the grid insert and you're ready to use it. It clips in place and it stays nice and secure. Bento 3D is a great way to quickly make a custom sized box, and I'm genuinely impressed how well it works. I was expecting the clasp to be too tight to easily lock or too loose to really hold itself together, but that works really nicely and it has a good amount of tension to easily unclip and clip back up again. And all the tolerances seemed absolutely spot on. But it's far from perfect. As I showed you earlier, there's a number of issues in the design process which may prevent you from making exactly what you're after, and there's no way to change the external aesthetics. I could design my own bespoke box from scratch, which would be better than this, but that's going to take a lot more time and effort than what this did. If you don't need a custom size, there are a ton of designs that you can download and print, and some of those are fully printable, meaning that you don't need the screws and locking bars that this requires. If, however, you do need a custom design and you have those parts available, this is a great solution to quickly and easily throw this together. This tool has been talked about before on other channels, but I'm sure there's a ton of people watching that didn't even know it existed, and it's for you guys that I made this video. I really hope you found this video useful, and I would love it if you would hit the like button and subscribe so you don't miss my future videos. Thanks very much everyone, and until next time, happy printing. You're still here, that's awesome, thank you guys so much. If you really enjoyed this video, you might like to join these guys below who are my channel members. Hit the join button below my video to find out what benefits you can get. For now, why not chuck on my custom dice tutorial where I show you how you can make dice like the ones I used in this video, or chuck on another one of my videos to learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.